Hi everyone, and thank you for coming to this week's Smart Cities Talk series. Today we have Dr. Lee. She is a professor in the School of Geographical Sciences and Urban Planning at Arizona State University. Her research interests include geographic information science with a focus on developing integrated and smart cyber infrastructure to revolutionize knowledge discovery in environmental and social sciences. With that, I'll turn it over to you, Dr. Lee. Thank you for joining us.
Thanks for the invitation. Can you see my
Yep,
slide fine? Okay, great. So today I'm going to introduce real-time GIS for smart cities and from a GeoAI perspective. And this work started from 2020 when I was co-editing a special issue with Dr. Betty and Dr. Goodchild on the same theme. At that time, we reviewed a number of real-time GIS data source as well as spatial analysis tools to support smart cities. And as we know, since then, AI has grown so fast, and we started to witness also the emergence of a field called the GeoAI. And the applications of a GeoAI in smart cities has also seen significant growth in the past few years. So today I'm going to introduce a few of that applications, including some of my own work. So what is GeoAI? In a nutshell, GeoAI is short for geospatial artificial intelligence, and it is a combination of geography and AI. We can understand it as simple as the application of AI models in geospatial research. Or at a more in-depth level, GeoAI is a transdisciplinary expansion of AI. We can integrate spatial principles and spatial theories to make the AI models better support geospatial applications. And not only that, we are hoping that our impact can go beyond the geospatial domain and to also contribute substantially to the general growth of the AI technology. So what does real-time mean? Oftentimes, real-time means the right time. This is a news you guys might heard. So this is a satellite image very close to ASU campus, and a pedestrian was walking across the road, and she was struck by an autonomous vehicle and also killed in this accident. So when we are integratingly utilizing like the technology like AI and autonomous driving techniques, we will also need to pay attention to how reliable and how safely these decision makings are. And if this driving system can take into account more real-time information, like to detect the anomalies on the road, and then this kind of sentencing could have been avoided. And the real-time also means life savings. So this is another news about how the researchers at the Department of Homeland Security are using AI to advance flood simulation and also evaluate the cost and impact for the flooding hazard. And if we want to gain a better understanding of the trajectory of hurricane, for example, we can actually provide the real-time actions that can help the cities and its citizens to become more resilient to the increasing occurrences of natural disasters. And in fact, the GeoAI can play a key role in support of a variety of smart city applications, like in smart transportation, smart disaster management, smart business, smart energy, and the smart and connected communities. And in the following slides, I will give you a few examples. So one of the most compelling form of AI's application is computer vision. So basically by analyzing the images or the videos from the surveillance cameras, we will be able to detect all these different moving objects like cars, trucks, and pedestrians. So we can analyze how busy an intersection is. And we can also detect the anomalies like overspeeding or violation of traffic rules automatically. And another applications of AI in smart city is to help build the smart and connected communities. For example, this is another applications of using AI to analyzing huge amount of satellite imagery. Like we can do land use change analysis. And we can also use AI to simulate the urban expansion and urban sprawl. And one of the very interesting research I found is to apply AI in urban heat island research. As you know, the Phoenix areas has a very strong urban heat island effect. And some of my colleagues do this interesting work of detecting from satellite imagery the existence of swimming pools in the neighborhood. So they're trying to find out whether more swimming pools will help to cool down the neighborhood than the others. So this is a interesting AI applications about how we can help to design different urban configurations and the urban future cities, so to help us to combat the urban heat island. And another application area where GeoAI can play an important role is for smart disaster management. For example, after the Hurricane Eta and Hurricane Iota struck Central America in November 2020, there are a series of questions that need to be answered. But Central America is not like the US, which do not have a lot of the data available. So answering those questions will become even more important, even more difficult. But it's also very important because we rely on the damage information, the on-ground traffic information in order to make the timely decisions. And here is one of our recent research project on building the nowhere graph, which is to use space and time to link the cross-domain dataset to build the knowledge graph that can help answer important societal questions. And this project is funded by the National Science Foundation, the Convergence Accelerator Program. So the phase 1 is about $1 million research project, and then phase 2 is about 5 million. These are the PI of this project, and the lead PI is Dr. Janowitz from University of Vienna. And we are also actually containing a very huge team of members coming from academia, industry, and government agencies and nonprofit organizations. So working together, we are using the cutting edge technology to help inform actions about disasters and other important applications. And one of the areas where ASU take a leading role is to use this knowledge graph and AI technology to support smart disaster management and humanitarian aid. So for example, after hurricane occurs, like the Hurricane Iota, we need to answer a few questions, like what is happening now? What are the on-ground information in real time? And we also want to know what happens in the past, because the past information will help us to make an estimate about which areas is more vulnerable in terms of damage. And some other questions like to whom this is happening, how many people are affected, who are the most vulnerable people and the communities in this area, and also what are the consequences, because after hurricane has hit the mainland, it will cause multiple cascading events like flooding, wind damage, and others. And we need to understand not only the direct impact caused by the high wind, we also need to understand the impact by the cascading disasters like flooding and also storm surge. And a final question is, what are the risks? So after hurricane has passed, there may be some disease outbreak. Like we are building this knowledge graph in terms of triples to encode all of this information. For example, North Carolina are experiencing hurricane struck, and then the sewer system was disrupted in this county. And also North Carolina has been undergoing some mosquito outbreak. So we are actually breaking this natural language text into this kind of triple form and then put it into a graph called nowhere graph. And then using this kind of knowledge graph technology, we can do question answering and also a number of decision-making support. So building such a graph, we need to integrate multi-source data, especially the real-time data when a disaster happens. This is how many data sets that we are using and integrating to support the smart disaster management. Like the first one is hurricane track. We actually included about 150 years of the past hurricanes from NOAA. And we also integrated the climate hazard data, which includes about 70 years of data reporting all the injuries, deaths, property damage, and other kind of damage to each county in the disaster affected region. And we're also interested in the social economic profile, like population, race, income, and all this basic information. And another important data set is public health, because we want to know the health conditions in the affected region, because some people who have diabetes or other kind of health conditions, they may need to take the medicines, which is put in the refrigerator. And after a hurricane occurs, there may be power outage. And then those are the people who are in urgent need of these medical supplies in order to survive from this kind of disaster. And what about public health facilities? Like when people want to seek help in terms of injuries, where are the hospitals are located? Where are the pharmacies and some public health department? And we also have integrated data set about expert and expertise, because making on-ground information really need the expert who have local knowledge, not just the knowledge about the general disaster and the disaster relief, but also about the local knowledge. And these are the different themes of data that we integrated. And we also integrated the place-centric data set, like administrative boundary, weather zones, climate divisions, and also the geographic name information system. So if you are interested in this approach of how to integrate this multi-source data, you are welcome to read our recent paper about it. And then after we identify all the needed data set, what we did is we built an integrated ontological schema, which you can consider it as a data structure, which help us to link these different types of data, like location ontology, storm track ontology, health index ontology, disaster expert, and also disaster impact. And these links showing how different modules, ontological modules, are connected with each other. And based on this schema, we are converting all of these data sources into this graph format, and then help us to make inference and also answer different questions. And after building the ontologies and also the large knowledge graph, currently the NOVEL graph contains more than 12 billion of these triples I showed you earlier. And using this information, we are developing a decision support tool called the Geographic Viz. And you can actually access it live from this web link. So I'll show you a quick demo about how it works. So on this like visualization platform, what we are viewing is at the very beginning is the 10 deadliest hurricane and their landfall locations in the North America. And if you are interested in one of them, this is Hurricane Michael, you can connect it, and then it shows as Hurricane Michael has moves, what are the different categories. So these are category 4, and then starting from here, Hurricane Michael has become a category 5 hurricane. And these circles shows the impacted area based on the wind speed. And we can also see the underground report about the disaster impact, which are the damage report from different counties. So as you can see, we can enable this animation to show as the hurricane moves, what are the impact report, like the damage report that has been submitted by different county. And here is a statistics and a summary about the damage caused by Hurricane Michael, like what is the max wind speed and how many states are affected, how many counties are affected, what are the total property damage, and other information. And as I mentioned, hurricane not only will cause damage because of the high wind, it will also cause damage because of the cascading event. Like we can see what are the damages caused by like storm surge, flood, flash flood, and other type of information. And we can also view this damage report. So when the impact started, when it's end, what is the property damage and the total deaths of people. So by integrating all this information together and build a knowledge graph, and also to visualize this information on a web portal will really help the decision makers and the relief expert to understand what is happening and what is happening in this disaster affected region and how to locate and these different medical supplies to send it to the most needed people. So I just showed you very quickly a few examples about how GeoAI can use to support different aspects of smart cities research. And I also showed you what we have been doing in terms of building the knowledge graph and using AI and cyber infrastructure to support the disaster response. But in this field, there are also a number of challenges. For example, open data is also always a challenge because GeoAI for doing supervised machine learning is data hungry. We always need to prepare a large number of training data set. So by having a community-based effort to developing some large benchmark data is really important. And another thing is smarter models. Currently, there is a movement from building very task-specific model to some foundation models that can do a large number of the different tasks. So we don't need to develop a very specific model for each task, which is related to what we are going to discuss now. So as you may know, the foundation models is becoming a very trending topic in AI and also GeoAI. And this kind of large models like ChatGPT, which works very well in natural language processing and can be applied to a wide variety of tasks. So in natural language processing and text analysis, the foundation models are doing pretty well. But in terms of image analysis and vision task, like if we want to analyze and detect the different objects or segment the flooding areas from the time sequence of images, the foundation model research still suffers from different challenges. Like this is one of our very recent paper of evaluating the IBM and NASA co-developed geospatial foundation model PRISVI in flood indentation mapping. So we found that although this model has been trained with huge amount of geospatial data, but compared to some task-specific model, they still are not performing as well as some of the cutting-edge models. So, which means in the computer vision domain, the foundation model still has a large way to go. And in light of that, we are organizing a upcoming webinar on November 13th, the coming Monday at 12 to 1 p.m. Eastern time. So we invited the research scientists from IBM Research to discuss their recent geospatial foundation models, which are targeting for image analysis. So if you are interested, the webinar registration link can be found here. You're welcome to come. And because the model, the IBM's model PRISVI is an open source model. So it's really give us the community an opportunity to contribute and also continue to make advancement in it. And some other challenges in terms of GeoAI research, including privacy, like we collect a ton of data, like tracking movement of people, we can use the body scanners, but all this the personal information needs to be carefully protected. So we are not reviewing any of this personal information. And another concern is about the digital divide, because in the cities, we are increasingly leveraging these smart technologies like AI, but this might also present a disadvantage to the poor people. This causing the brain drain in rural areas. So addressing this issue to remove this digital divide in the era of AI and GeoAI is becoming very important concern for us as researchers and also for the decision makers. Okay, so this is a brief review about our work. Thanks so much for your participation. And if you have any questions, I'd be happy to answer.
Yeah, thank you very much, Dr. Lee. We appreciate it. I have one quick question to sort of start us off while people think. I suppose with the nowhere graph is incredibly impressive visually. It's really, really a neat looking portal. Have you been able to use any sort of I saw a lot of those hurricanes that happened in the past several years and going back quite a few. Have you been able to apply that sort of nowhere graph to any hurricane or event that happened since it has been built, or was this all built on previous sort of data?
That's a very good question. In fact, as we build it, we are also enabling the integration of real-time information, because we are not only want to analyze what's happening in the past, but also to really help to provide this decision support for what's happening now, and also what's happening in the future. So one of the data source we integrate is a real-time hurricane projected information from NOAA as well. So I think at October 2022, we are actually using this portal to track the hurricane that happens in October. But is that Ian? Yes, I think it's Hurricane Ian. So we are showing what's happening as Hurricane Ian is moving near the coast. And we are also showing, if you are log on to our latest portal, we are also showing the health profile of different regions. So what we did is we are showing where in the next few days that Hurricane Ian will move to. So which areas may potentially be affected. And we can also visualize what are the health profile in different regions. So our collaborators from disaster direct relief can really utilize this information in terms of distributing the medical supplies. Yes, so my answer to your question is yes, we are integrating the real-time information to support decisions.
Thank you. That's really impressive.
I have one question. Thank you, Dr. Lee, for amazing presentation. So my question was, even though we are planners, we're kind of getting adaptive to the changes and starting to employ new emerging methodologies similar to your work. But what would be the best way to leverage of demonstrating our results to the public and general audiences? Because as a researchers, we get to understand what you're implying. For general audiences, it might be a little trickier. And since we're planners, we do like community engagement and we do community participatory planning a lot. And I'm more interested in how you, in your personal opinion, think about the best ways to convey our results to the public.
I think storytelling, science storytelling is very important, right? As you said, we can generate a lot of tables and figures to show our result, but they may not be as easy to comprehend to the community and also local decision makers. So what we have been doing is develop these tools to convert those complex data sets. So if I show the nowhere graph to those community planners, they probably would not understand what that is about. That's why we also developed this web portal to convert this very complex data set and the connections in a more easily understandable way. But although we developed this portal based on a lot of the discussions with our collaborators, which are the relief people, the disaster relief people from the nonprofit organizations. But I think keep doing this outreach, getting feedback to know what is exactly they need and how to present this information through an effective sense storytelling way is very important. Like we always say, a picture worth 1,000 words, right? So converting the complex textual description into some visually appealing and visually comprehensible form I think will become the key for communication.
Thank you.
Thank you, Dr. Lee. Thank you so much for your amazing presentation today. I have two questions actually, because I'm also doing something like the location function encoding works using the different data sources, the multimodal data sources and the graphs. So the first question is like, since sometimes we cannot get all the data, all kinds of data sources, right? So what do you think, like, which one is important? Like the data source is important, or how to construct your graph, or your the structure of your model is which one is more important? And is there a balance, or if we don't have enough data source, is there a balance to deal with that? Yeah, and my second question is about the scale. Like, I know like we can extract knowledge from different data sources, right? So if it comes to the scale, like, can I get some knowledge, specific knowledge for like each row segments, or for census tracts and for city scale? So they are pretty different things. So what do you think, like, if we want to know different scale informations from all these data sources and from the graphs, like, do you have any advice or like any ideas about that? Yeah, thank you.
Yeah, I think this is a hard question. What I would say is which data set is critical is depend on your research question, right? Like if we want to get some attributes about some road segment, and if that road segment, like speed and how many lanes does this road has, is critical to answer your research question, then we will need to get this data set somewhere. So there are two approaches. One is we go to like DOT or some other government agencies to see whether they provide this data set, or if you have some connections with those government agency folks which can help you to get those data more easily. But if you cannot get this data set, but this data set is critical to answer your research question, another way is you mentioned about multimodal data analysis. So, you know, using satellite imagery analysis and also combining with the other crowdsourcing data set like OpenStreetMap or some other even social media data, it might help us to build like this substitute data set that will contains the needed information for your research. So the balance is really depends on, I think, your research question. And what amazing for GeoAI is, you know, we have increasing amount of data that's becoming public available. And we have multi-source, multimodal data, and which we can leverage to get this information that we need. We have much more, actually, much more information that to help us to support different research than before. So those are also a possibility for us to get the information and get the data if they are not readily available.
Thank you very much.
I have a question.
Yes.
Can you hear me?
Yes.
Thank you, Dr. Lee, for your great presentation. It was really impressive work. My question is about the application in practice. So I wonder, maybe does the nowhere graph also provide some prediction for some hurricane affected areas? I think it could be a really powerful tool set with many possibility. For example, it could provide, maybe it can predict some evacuation route or some hospital demand, or maybe it could be prioritize people who would be more need more help the most. So are you envisioning to develop any kind of prediction models, or how it could be much impactful from the application perspective?
Yes, I think this is a really good suggestion. We, like in the past few years, we have been so busy of building this graph by integrating multi-source data. And the areas that we haven't moved into a lot is this prediction capability, which is very important. So we build this data set, we build this knowledge graph, which can help us to answer a number of questions. But as you are seeing now, without this simulation capability, we have collected this data and get them graph and AI ready. But if we can in the future also ingest and integrate some prediction tools which can utilize our data set, that will be even more powerful, right? So from application perspectives, we can really help these local decision makers using our portal to see what's happening and like to plan some evacuation route or locate the people who are in need of the urgent help. So we are trying to find those collaborators because we cannot do everything by ourselves. So right now it's an interdisciplinary research world. So if you or any other colleagues from UT Austin who's developing those simulation or prediction capabilities, we can certainly leverage our our strengths of doing an even bigger efforts to make the impact and support different applications. So thanks for your suggestion.
Thank you.
Right. If there's no more questions, we can wrap it up. I know everyone's on a bit of a tight schedule on Friday afternoon. Is there going once, going twice? All right. Well, thank you very much, Dr. Lee, for your time. I really appreciate coming to speak with us. I'll make sure your contact is available for everyone later on for any follow-up. But for now, thank you very much, and we'll see you at the next talk series.
Thanks, everyone. Bye.